So today we're going to be doing the station activity review. Please check and mark if a compound contains electrolyte and non-electrolyte. So guys, we said electrolytes are acid, bases, and salts, or ABS. Non-electrolytes are alcohol or sugar. Those are the CHO groups. Carbon, hydrogen, oxygen. So, carbon, hydrogen, oxygen. CHO, non-electrolyte. Carbon, hydrogen, oxygen. CHO, non-electrolyte. H in the front, according to table K, when you have a hydrogen in front, that's always an acid. Acid are electrolytes. CHO is on table K as well. That's acetic acid. Acids are electrolytes. A metal with the OH, that is a base. Base are electrolytes. A metal and a non-metal on your periodic table is a salt. Salts are electrolytes. When a compound starts with just carbon, CH4, that is a non-electrolyte. Yes, I know. How come CHO starts with a carbon? That's the only one, that's the only exception, guys, all right? Moving on. Carbon, hydrogen, oxygen, CHO, non-electrolyte. Carbon in front's always a non-electrolyte, guys, except for CHO. Metal, OH, base, electrolyte. Carbon in the front, CHO, non-electrolyte.
Sorry, what device?
Station 2. Write down whether compounds an acid or a base. Again, guys, use your tables K and L to assist you here. Hydrogen in front, acid. If you go to table L, NH3 is ammonia, base. Metal, OH, base. Go to table K, CO2. In water, carbon dioxide in water, is carbonic acid. Hydrogen in front, acid. CHO, acid. Metal, OH, base. Hydrogen in front, acid. Station 3. Here we go. We said, remember when we do to determine bronzolary acid-base pair, we must first connect the compounds that look the same. H3O looks like H2O. The one that has one more hydrogen is my acid. This says 3 hydrogens. This says 2 of the pair. The one that has one more is the acid. The one that has one less is the base. Now connect the other pair. This is 3 hydrogens. This is 2. The one that has one more is the acid. One less is the base. Next. We said acid donates, base accepts on the same side. Acid donates, base accepts the hydrogen ion. Okay, moving on. Next one, CHO. With the guy looks like CHO, but this guy's missing the H in the back. You notice that? This guy has the extra H. The one that has one more is your acid. One less is the base. This is your base, and this is your acid, because we said, remember, you can never have 2 acids or 2 bases on the same side. So remember, we learned acid donates, base accepts the hydrogen ion. Acid donates, base accepts hydrogen ion. Next, connect them. NH3 connects with NH4 plus. 4 H's, 3 H's. The one that has one more is our acid. One less is the base. If this is the base, this must be the acid. If this is the acid, this must be the base. Acid donates, base accepts. Acid donates, base accepts. Last one. Let's look at a different color here. H3O connects to H2O. 3 H's, 2 H's. The one that has one more is our acid. One less is the base. If this is the acid on the left, Cl must be the base. This is the base, this must be the acid. Because when you connect them, the one that has one more is the acid. Acid donates, H plus, base accepts. Acid donates, base accepts. Let's move on. Forget about station 4. doesn't work because you have to actually physically do it. Station 5, fill in the blanks. Here we go. We learn pH plus POH equals 14. We learn H plus times OH negative ions equals 10 to negative 14. So, if my pH is 1, my H plus is 1, my pH is 1. If my pH is 3, my H plus is 10 to negative 3. Do you see the pattern here? 3 goes with 3, vice versa, 1 goes with 1. Good. We learn that pH plus POH equals 14. So if my pH is 1, my POH is going to be 13. 1 plus 13 gives me 14. If this is 13, OH goes with OH, correct? If this is 13, this would be 10 to negative 13. Now, what determines whether a substance is an acid or base is the pH scale. We learned under pH of 7 is an acid. 7's neutral. Above 7's a base. So, pH is 1. It's under 7. Acid. pH is 3. POH 3 plus 11 gives me 14. If that's 14, this is 10 to negative 11 as well. So pH under 7 is going to be an acid. Now they gave us OH negative. Well, OH negative is negative 5. That means this OH must be 5 POH. 5 plus what gives me 14? 9. If the pH is 9, H plus is 10 to negative 9. Because it's the same numbers. Sorry, my handwriting is terrible. We learned pH is above 7, it's a base. Next, pH is 4. This would be 10 to negative 4. Well, 4 plus what gives me 14? Correct. 10. So if the POH is 10, OH negative is 10 to negative 10. And so on and so forth. So pH is under 7, so it's a acid. Over here they gave us neutral. Neutral means pH 7. So POH must also be 7. 10 to negative 7. 10 to negative 7. Okay. I'm not going to do the last two. You can do it yourself. Moving on. Station 6. So let's read what it says here. Sample of soil is pH of 5. When HCl is added, well, that's the acid. A new solution is 1,000 times stronger of the H plus, which is the acid. What is a new pH? Well, let's write a temporary pH scale here. 3, 4, 5, 6, 7, 8, 9. I'll stop at 9. I'm not going up to 14. pH is 5. Remember we learned, as you go down, it's 10 times stronger. 10 times 10. Well, so far 10 times 10 is 100. We need how many? 1,000. So we got to do it again. Times 10. 10 times 10 times 10 is 1,000 times stronger. Thus, my pH is going to be 2. Any questions? Always hit me up. If you have a question, I'll remind. Moving on. What is the pH? Well, HCl is an acid. It's the number of spaces you move to the right in front of number 1. 1, 2, 3, 3. H is an acid. H in the front. 1, 2, 3, 4, 5, 6. pH is 6. What makes NaOH different? Well, NaOH is a base. Base. It's the number of spaces you move to the right minus 14. So 1, 2, 3. 14 minus the 3 spaces, 11. 1, 2, 3, 4, 5, 6. 14 minus 6 gives me 8. Okay, let's move on. Station 7, complete the reaction. Well, we learned about positives and negatives. Element by itself is a positive. Compound is split up into positive and negative. Opposites attract, so the positive will go with the negative. So you get MgCl. Are we done? No. We must look at the charge on the periodic table. Mg is plus 2, Cl negative 1. Can I reduce 2 and 1? No. 2 comes down. So I get MgCl2 plus who's by himself over here? Hydrogen. What's special about hydrogen? It's a part of that family called Brinkelhoff diatomic, so it's H2. Let's go on to the next one. Li is plus, positive, negative. Opposites attract, so Li combines with SO4. Plus 1. Go to table E. Table E, SO4 is -2. I cannot reduce 1 and 2, so the 2 comes down. So you get Li2SO4 plus H2. How's the last one different? Well, the last one has compounds. So again, H2 is the, I'm sorry, let me avoid. H2 is the positive, hold on. H2 is the positive, SO4 is negative. Ca is positive, OH is negative. This is an acid. Acid and base equals salt and water. Yes, I know. Acid and base equals salt and water. H2 goes to OH. No, it's not H2 and OH2 is H4. It's always water. Next, Ca goes to SO4. My kids are laughing. Ca is, you gotta look at the charges. On the periodic table, Ca is +2. On table E, SO4 is -2. Well, what are they gonna do to each other, guys? That's right, they cross out. So you're left with H2O plus CaSO4. Let's move on. Last question is actually over here on my, a second over here. There it is, right there. Okay. Oh, I can't write it. All right. Well, I actually have it for you over here. I'm sorry. I actually have the answers over here. You can just look up the sheet over here. Okay? And I showed you this is the titration formula MAVA MBVB. And titration 5 milliliters of 2 molar. So those two must go together on the same side. NaOH is the base, so it goes on MBVB. So it's 2 times 5 gives you 10. And neutralize 10 milliliters of HCl. Well, that's the volume of the acid. That goes on that side. And then you cross multiply and solve, and the answer is going to be 1 molar.